All right, what do you say? Let's get this party started. Can you guys go to your notes from yesterday? And I told you guys I was going to finish question B. So let's do that right now. Yesterday's notes, number 5, letter B. We're going to finish right now. And just a reminder how important it is, especially now that we're virtual, that if you guys miss a day, you got to watch the lesson on YouTube. All right, this stuff is tough as it is when we're in class, let alone if you miss a day. All right, so you got to pick it up whatever you missed. All right, ready to roll? All right, first thing we have to do for part B is graph it on the XY graph there. 13 pi over 8. Everyone sees that my angle has a pi in it, so that's how I know I'm in radians right now. Not degrees anymore, I'm in radians. But I only know, and I've only taught you guys how to graph an angle in degrees. So what you need to do first is, hey, let's take our 13 pi over 8 and let's put it into degrees. How do I do that? I go to my formula sheet. On the formula sheet, left-hand side, you look for radians because that's what I started out in. I start out in radians, so that's what you guys look for. And then you see to the right what it's equal to. That fraction is what we multiply by. So everyone, real quick, take a look. What am I going to multiply 13 pi over 8 by, according to my reference sheet, if I can use it correctly here? Let's do this. Here we go. Sophia, you weren't here yesterday. That would be unfair of me. How about 5? Here we go. Ella, what should I multiply by?
180 over pi.
180 over pi. Perfect. And sometimes this happens and sometimes it doesn't. In this case, it does. The pi's cancel out. Sometimes, you guys saw yesterday in the notes, the pi's not there. So I don't cancel it out, but this time I can. So now I go to my calculator and I'm doing 13 over 8 and multiplying that times 180. That's exactly what I have left here. And the calculator tells me, 585 over 2. I'm going to change that into a decimal because we're talking about degrees here. So I'd like to see something other than a fraction with a degree. So we hit our math. If you guys have 585 over 2 as well on your calculator, we can change that to a decimal by going to the math button on the calculator. And choice 2 says turn anything I need to in a decimal. So that angle as a degree is 292.5. All good? Converting? All right, now all of you, whether you were here yesterday or not, should be comfortable with telling me what quadrant 292.5 should be in. So what quadrant am I working in, guys? 292. Hunter, what quadrant? 292.
4.
Quadrant 4, good job. So again, my initial side's always on the x-axis. 292, only thought you need to figure out is it closer to 270 or 360? And 292 is going to be closer to 270, so I make it that way. Please do not forget your arrow. Which direction is 292 going? Boom. Counterclockwise. All right. I'm not going to show you how to graph an angle in radians. I always prefer you guys turn it into degrees. We're all good on that part. All right, you guys notice there's a second part, which is find the reference angle, and it's got to be in radians. Find the reference angle. Okay, reference angle, I do this all the time. Terminal side and x-axis. Terminal side and x-axis. I need somebody to tell me how I can find that angle right there. I'll just put REF for reference. Find it in degrees first. Let's find this in degrees, and then we'll convert it over at the end. So your reference angle. This is usually the tough part for kids. What numbers do I have to play around here with to get that angle that's left over in the middle? Thoughts? Here you go. Bassett, what do you want numbers you want to play around with?
360.
Yep. And what do you want to do with it?
Subtract them.
Good job. Never use 90, never use 270 when working with reference angles. And, okay, what's that? 360 minus 292.5, 67.5 degrees. Which is good to me. Why? It's less than 90 and it's not, and it's positive. That's what every reference angle should be, less than 90 and positive. Problem though, right? What did my final answer have to be in? The reference angle in radians. So how do I take 67.5 degrees and convert it to radians? That's what we did yesterday. Back to your formula sheet. Woo! Back to your formula sheet. Now you look on the left-hand side to where it says degrees, because that's what I'm starting out with now. So I have 67.5 degrees. What's that fraction on the reference sheet that you multiply by now to get it into radians? What do you got for me, Nick? What's that fraction?
Pi over 180.
Good job. I'm going to multiply by pi over 180. Remember, radians, your answer in radians should have a pi with it. Okay, so keep that pi out of your calculator. Don't type in the pi symbol. Keep it out. What I do need you to do, though, you guys that weren't here yesterday, is you need to take 67.5, 67.5 over 180 and reduce that as far as it will go. And your calculator will reduce it for you. Oh, maybe, hey, I got 0.375. Everyone else getting that on their calculator? If you wanted to, you can put 0.375 pi. I prefer it as a fraction. So I've been trying to tell most of you how to turn a decimal into a fraction all year, and that's hitting your math button again. So let's hit our math button. Turn number one now, turn it into a fraction for me. 3 over 8. So 3 pi over 8 is my reference angle in radians. How do we feel? We all right? You guys feel comfortable converting degrees to radians, radians to degrees? That's the big thing I needed to get out of yesterday without a doubt. Well, we feel comfortable. Anybody want to ask? Here's a session right now. Any questions? I'll take a minute right now. Any questions that you guys have? Because I'm going to do something new with radians today. We okay on where to look on the formula sheet? And it's important to me because you need this ability to be successful the rest of the unit, be able to convert back and forth. Any last general questions before I move on to today's notes? Everyone doing all right? Anybody feel like me and just this whole remote thing is awful? This is not how I should be teaching, to a computer screen in an empty classroom. All right, you ready? Let's do it. We got to keep the train going, though. No excuses. No excuses. Not even by me. Suck it up, Mr. Carlino. Let's get going. All right, make sure we're on day 2 of radians. Day 2, 3.4. All right, my plan before we went all remote was to show you this nice YouTube video to introduce you to the topic today, but it's not going to do the same when you're just watching it from home. All right, I'm not going to put you through that pain. All right, so I apologize. If you want to go there on your own and see what the video is like, feel free. Okay, but it's not going to do anything when we're all remote. So here is under conclusions. We wrote this down. You guys that were here yesterday, we wrote this same thing down, but I want it reinforced right now. 360 degrees is equal to what in radians? This is a conversion that I need pretty quickly. And I don't want to go to the reference sheet. We don't have time for that anymore. And honestly, you're better than that now. You don't need to go to the reference sheet anymore. Anybody remember what we wrote down? 360 degrees is the same as?
2 pi.
Yep, 2 pi. 2 pi. Not 2 radians, 2 pi radians. All right, so if you're wondering why we write 2 pi, that's how many radians right there, 360 degrees. It's about 6 and change. Okay, 6 and change. And we do not want to write that full decimal down every time we say 360 equals 6.283185 307 radians. So we say 2 pi instead, which is the same thing. But that is how many actual radians 360 is equal to. All right, a couple more practice problems with radians before I get into the brand new topic. Hey, everybody. What quadrant would an angle of 2 radians be? An angle of 2 radians would be found in what quadrant? I have no idea. But I do know if you told me a degree measure, I could tell you what quadrant we're in, right? So why don't we take 2 radians and convert it to degrees, and then we can talk to each other. So I got 2 radians, and I need it into degrees. What are you guys multiplying by according to your reference sheet? What should I be multiplying by? Hopefully we're getting better at this, because I know every year believe it or not, the huge sticking point is which one to use on the reference sheet. Here we go. Hunter, you weren't here yesterday, but I bet you would know anyway, but don't want to put you in that spot. Katie, here we go. What am I multiplying 2 by to turn it into degrees?
180 over pi.
Good job, Katie. 180 over pi. And hey, guys, we said this happens. There are no pi's to cancel, correct? Don't cross off that pi. There's nothing to cancel it with. Sometimes you can, sometimes you can't. So how do I figure out how many degrees? Multiply the 2 in your calculator right now. 2 times 180 over pi. So we're looking at about what? 115 degrees? So 2 radians is about 115 degrees. Making it in what quadrant? What do you got there, Sophia? You can answer this one. 115 degrees would land in what quadrant?
Two.
Quadrant 2, got it. Between 90 and 180, quadrant 2. All right, I'll give you guys, you should probably only need a minute. Go ahead and try number 2 out. 7 radians now. Where am I at 7 radians? So I'll give you a minute to try that one on your own. 7 radians. Okay, how are we doing here? I was interested to see what you guys would do with the degree measure you ended up getting. No pi's to cancel. Got about 401 degrees. Some of you guys could probably figure that out, where 401 would be. If you don't like 401, how could I have made 401 a little smaller? So I got it less than 360. What could if I didn't want 401, I don't feel comfortable doing 401 degrees because I only like angles that are less than 360. What could I have done to the 401? Here you go. Dan, what could I have done to the 401?
You could have subtracted it by 360.
Absolutely. So if you don't like that, guys, it's a little too large for you. Subtract 360 from it. and you got a nice angle that was 41 degrees. And I'm not even going to ask anybody. We know that that's in quadrant 1. All right, you guys good? Quad 1? All right, let's move on. How many radians in 180? But wait, whoa, hold on. You're not allowed to use your reference sheet. No reference sheet here. How many radians are in a buck 80? Ooh, no reference sheet. Get away from it. Don't cheat. You already know what from the top. Look, you already know what. 360 is equal to 2 pi radians. We already know that. That's ingrained in us. What do you think about 180 then? What's the real, 360 to 180? Ooh.
I know.
You think you got something there, Caroline?
Yeah, it's just 1 radian because it's 180 is half of 360.
Okay, all right, well, easy. Okay, so Caroline said, hey, 180 is half of 360, right? So you would just cut 2 pi in half, but you don't get 1 radian. If I cut 2 pi in half, what's it come down to?
Pi.
Just pi, yeah. It's just pi radians, everybody. Not, you see the difference, Caroline?
Yeah.
1 radian means just 1. Pi is that 3.14 radians. Okay?
Yeah.
So it's a little over 3 radians. Everyone see how Caroline got to that? Good job. I just take half of 360, so I took half of 2 pi and got pi. Ooh, what about the other quadrantal angles? Ooh, quadrantal? Let's review those real quick. Remember, I got 0, 90, 180, 270, back to 360. All right, well, we already know 180. We just went over that one, right? 180 is equal to pi radians. We already went over that. We also know 360 is 2 pi. All right, what about 90 now? What do we think? 90. Anybody think they could find 90 without going to the reference sheet? How do 90 and 180 relate? 90 is
Half of 180.
half of 180. So I'm going to take, again, half a pi. So we're going to say not pi, but pi divided by 2 radians. And again, I don't want to write that long decimal out, so I keep it pi over 2 to keep it nice and clean. All right, what's the only quadrantal angle we're missing here? 270. And I'm just going to give this one to you, all right, instead of just playing around and see if we can find a relationship. Ready? 3 pi over 2 radians. Three pi over 2 radians. That's going to be huge tomorrow. Questions there? Pi over 2, pi, 3 pi over 2, and 2 pi as I go around. Anything? Okay, so there's a good recap of all the radian stuff, because what I'm going to show you now is brand new, and then you guys can start the delta math because there's not much here we got to do. All right, let's hold off on number 5 right now. All right, let's hold off on number 5. You guys can just follow what I'm doing up here. All right, real quick recap of a geometry concept. That's a circle. Okay, that's our geometry recap. That's a circle. If I draw, this is my center, and I draw this line inside the circle. Anybody know what that's called?
Radius.
Thanks, radius. All right, so we're all familiar with the radius. If I draw in a second radius in the same circle, What should I know about these two radii here? If I draw another one in the same circle, anybody know what I should know about both radii?
They're concurrent.
Concurrent?
Wait.
God bless your geometry teacher, Caroline. Concurrent, take the C out in concurrent and change it to a G.
Congruent.
There we go. Congruent.
I almost said congruent.
Are you done? Okay. Congruent, yes. And when I draw both of those angles in, does everyone see an angle that I formed? Everyone see the angle I formed by drawing in the two radii? That's called a central angle. And I'm just telling you guys this now because you're going to see this vocabulary in a second. That's called a central angle. And if I go to each point where the radius ended, you see how it forms this part of the circle? And I'll just throw it. Hey, you can show off right now. Anybody know what a part of the circle is called? What I just highlighted up there in yellow? That's called the what part of the circle? Begins with an A, R,
Arc.
arc. It's called an arc. Yes, it's called an arc. All right, that part of the circle from the two radiuses. All right. I just wanted to throw that out there because we're going to start seeing some of this. Okay, let's go back to the questions now. Let's go to number 5. I just want to set up the diagram first. Can you help me set up the diagram? I have a circle. Radius is 4. So everyone draw your circle with a radius of 4. And you also want to draw in another radius of 4 because I need to form an arc here. All right, 4 and 4. And the intercepted arc, the arc measure, the arc that's formed by those two radii is 8 units long. All right, so I got my two radii. The arc that everyone sees the arc that it forms is 8 units. How many radians would be in the angle that's formed? Okay, so everyone see the central angle you formed here? How many radians would be in there? And I'm not expecting you guys to know that because I haven't given you the formula yet. But I want to make sure you can draw the diagram first. Any questions about the diagram? Radius of 4, arc length of 8. What's the angle formed in radians? Everyone's all good? Any questions? All right, bring it to another level now. The formula I'm going to need today, my new formula, is not on the formula sheet. It is not on the formula sheet. Unfortunately, yes, you do have to remember this one. Is the following. It's a short one, though. It's a short one. If I have an arc length and a radian measure and I'm trying to find the angle, I find it the following way. Remember our Greek symbol from yesterday? Anybody remember what that was called? That Greek symbol? Come on, kids. You were here yesterday. What was that one called, that Greek symbol right there we just drew up?
Theta.
What is it?
Theta.
Theta. Good job, Ella. Theta. Yes. Everybody, that's my angle in radians. Sorry about my sloppy handwriting. That's my angle in radians. And that angle is always equal to, ready? The arc length, which we're going to call S. That's the arc length. Divided by the radius length. That angle can always be found by taking your arc length and dividing it by the radius length. All right? Get used to that formula, please. You need to know that one. Not on your formula sheet, but hopefully you guys use it enough that it'll just become second nature. All right, so let's go back up to problem number 5. We needed to find what the angle was in radians, and I knew the arc length and the radius length. So theta equals S over R. So you guys help me plug it in right now. The angle theta, the angle I'm looking for, is going to be equal to What is the arc length in this problem? Arc length. Come on now. Woo. Caroline, what's the arc length?
Oh, I'm not ready.
Oh, it's okay. Sorry, I'm going too fast.
Okay, arc length, 8.
8 divided by, what's the radius length?
4.
4. So the angle, everybody, will be 2. Not just 2, it's not 2 degrees, it's just not 2. It's 2 radians. That angle is always in radians when you use that formula. All right? Everyone okay on how I can find that angle now, given the arc length and the radius length? Questions? Because I want to pick up the pace just a bit now. Theta is your angle, S is your arc length, R is the radius. All right, number 1 down here now. Draw your diagram. You got a circle with a radius of 1.7. I always like to draw in a couple of them. 1.7. What's the length of the arc? Okay, so now we're finding a different piece. We're finding the length of an arc where your angle now is 2 radians. So 2 radians inside here. And do you see what I'm asking for now? The arc length right here. How long is that arc? Which we call in the formula S. So I have the angle and the radius. What's the arc length? Well, let's plug it into the formula and figure it out. Is anybody impressed by my lowercase cursive s, by the way? Cursive. All right, never mind. All right, help me out. Let's roll. Woo, here you go, Nick. Going to you. Nick, do I know what the angle measure is here?
Yes.
What is it?
2.
So 2 radians, so 2 gets plugged in for theta. 2. Nick, do I know the arc length here?
No.
That's what I'm trying to find. So you guys can keep S if you want. If you feel more comfortable with an X, go ahead. And Nick, do I know the radius length?
Yeah, it's 1.7.
There you go. So I'm going to plug in 1.7 for R here. Now my question, you guys know how to solve this? Last problem, you just divide the numbers, I was done. Can you guys solve this at all?
Yeah.
Go ahead then, Caroline.
Multiply each side by 1.7.
Yeah, multiply both sides by 1.7. Some of you guys maybe, if this is over 1, you can cross multiply. Remember those days? All right, but yeah, go ahead and multiply both sides by 1.7. And then what did that arc length come out to be?
3.4.
Oh, okay. 3.4 inches. All right. Guys, I will always give, there's 3 pieces to that formula, right? Your angle, your arc length, and your radius. I will always give 2 of those pieces to you. You're on the hook for the last piece. Any issues? All right, we're almost done, and then you guys can get questions. Sorry. Nope, never mind. False alarm. And then you guys can get started on the delta math. All right. Sometimes, though, I'm not going to come out and say radius. I'm not going to come out and say arc length. I'll put it into an actual real world type of problem. Here comes our pendulum again, right? Oh, that guy and his pendulums. Swings through an angle of 0.55 radians. Okay. What distance does the tip travel if it's got a length of 8 feet? Ooh, all right. Wow. Well, all right, let's go. What's this 0.55 radians? What's that going to be in our formula? 0.55 radians, that angle measure. What's that going to be as far as our formula goes? You go thoughts, here you go. Ella, what's that going to be?
So
It's
it would be
it's the angle, right? It's the angle. So what's that going to, what am I going to plug it in for?
would we plug it in for the theta?
Yeah, right? Because that's the only one that means angle. Everyone see that? Good job. It's just the angle. S is arc length, which that's not, and R is radius length, which is not. So it's the angle is 0.55 radians equals, all right, let's keep reading. What distance does the tip travel if it has a length of 8 feet? So we got to figure out what this 8 feet is. It has a length of 8 feet. The pendulum has a length of 8 feet. Oh boy, I'm not even going to do any of this justice. There you go. There's your pendulum, right? It's got a length of 8 feet, and we want to know how far it travels back and forth here. So what do you think that 8 feet is going to be in my formula? Is it the arc length or is it the radius length here? Anybody have a thought?
Would it be the arc length?
Well, remember here, we're trying to, and I know I don't like the wording too much. What distance does this travel here? So we're looking for this pendulum travels, we're looking for how far it travels here. So this right here would be part of my arc length. When I know the pendulum is 8 feet long. Okay? If I made, I don't know, does it help if I make a little bit more of a circle there? How far it moves? Do you see the arc length here is what we're looking for? And 8 actually ends up being the radius. Because we're looking for how far the tip travels. So as it swings back and forth, it's making that arc. And then we're solving for S, the arc length. Tough one there, tough one. So what do we end up where? I don't have my 4 point. Is this 4 point? I'll just figure. Come on. 4.4? 4.4 feet. All right, a little tougher there because it was kind of tough to decide what the pendulum was there. Was it the radius or was it the arc length? All right, 2 more. Another pendulum question. Now it swings through an angle of 30 degrees. And now I tell you the length of the arc. Everyone see that? Travels along an arc length that's 4 pi. Find the length. Hopefully you guys aren't getting ahead of me here because this one's got a trap in it. This one's got a trap. I got to pick up my energy here too because we're low now. We're low. Here we go. Mason, going to you. What's my angle in this problem?
Your angle is 30 degrees.
30. So usually, I've been telling you guys all class, plug in the angle for theta, right? Not this time. Stop. I cannot plug in 30 for theta. Here's why. Let me go back to the formula I had given you. Theta is an angle, but it's got to be in radians. This formula is specifically designed for any angles in radians, not degrees. So I cannot plug 30 in there. Anybody got a solution to my problem? If I can't plug 30 in there, maybe what should I do first?
Convert it into radians.
There you go. Yeah, off to the side. Good thing we know how to do that, right? Take 30 degrees and convert it into radians. And I'm not going to even ask you guys because I want to pick up the pace a little bit. Pi over 180. Multiply by pi over 180. Keep the pi in your answer when you're giving me radians. Only thing I need to do is reduce 30 over 180. And you guys do it on your calculator. It's 1 pi over 6 when it reduces down to 1/6. That is what you plug in for theta in this problem now. So pi over 6 equals arc length they gave me, right? What was the arc length again? The arc length is 4 pi. And how long's the pendulum, which is our radius? How do you solve that for R? Anybody want to show off algebra skills? How do I show off that? How do I put that? How do I solve this one? Anybody want to take a stab at that? How do I solve that one?
Do you have to make a common denominator?
No, you're not adding.
Oh,
You're not
yeah.
adding or subtracting. Ready? Remember these days? Cross multiply. Pi times R equals 6 times 4 pi, which is 24 pi. What do you guys want to do now to get the R by itself?
Divide by pi.
There you go. And what happens? They cancel, and I'm just left with the radius to be equal to 24 inches. We okay? And last problem here. We do need to know how to do these. What's the positive radian measure, the smaller angle formed by the hands of a clock at 5? All right, so guys, go ahead, draw yourself a clock at 5 o'clock for me. Draw yourself a clock going at 5 o'clock. I got mine right up here. Look at that bad boy, nice. I love that one. Here you go, 5 o'clock. What it's asking us for, in radians, what's this angle right here, the smaller of the two? What's that angle in radians? Hey, guys, did we mention a radius at all here? Anybody see radius? Me neither. Anybody see arc length? Me neither. All it's asking for is what's that angle from 12 to 5. So no theta equals S over R here, none. But we do need to figure out what that angle measure is. All right, I'm going to give you guys a little boost. If I went all the way around, 12 to 12, how many degrees am I going? 12 to 12.
360.
Right? 12 to 12 is 360 degrees. And you see these little minute marks? Little tick marks here, the minutes? How many of these are on the clock? I'm not going all the way around. How many of those minute marks are on the clock?
60.
All right, so I can take 360, divide it by 60 equal minute marks. I'm asking you this because every time you go a minute on the clock, you're going how many degrees now? Every time I go 1 minute on the clock, I'm going 6 degrees. Everyone agree? I'm going 6 degrees, 360 divided by 6. All right, so if I'm going 6 degrees every time, and I got to go all the way to the 5, how many total degrees am I going now? Remember, every minute you're going 6 degrees. So how many total degrees am I going to go to get to from 12 to 5? How many minutes are you guys going from 12 to 5? That's going to be 25 minutes, right? Not 5 minutes, 25 minutes. So you're going 150 degrees. From 12 to 5, you're going 150 degrees. But your answer has to be in what? Radian measure. Convert it. That's how we're going to end it. You're going to take 150 and convert it. I don't shy away from this question. It could be what's it at 2 o'clock? What's it at 3 o'clock, the angle measure? So convert 150 to radians. Come on, let me see what you got. Who's going to finish this off today? When you get it, let me know. Colin, when you get it in 150 in radians, let me know.
2.6.
Oh, how you getting 2.6? Remember, Colin, you got to leave your pi in the answer. You don't put all of this into your calculator. I think that's probably what you did. You put all of it into your calculator. You got to keep the pi in your answer and now do 150 over 180 and let me know what it is as a fraction.
Five, 6.
There we go. So this is 5 pi over 6. All right, that's the angle measure from 12 to 5. 5 pi over 6 as radians. All right. Guys, I apologize. I didn't give you any time to start, but you got to help me out here. All right, you got to practice a little bit for me. Okay, it's right on Delta Math. It's not too many questions. Please practice this stuff. It's the only opportunity you have. All right, we'll bring this back tomorrow. Let me know if you have any questions, and please practice if you can. All right, I'll see you guys tomorrow. I'll try not to go the full time tomorrow. I hate that.